Alright, this is review worksheet for chapter 10, page 1. And in the first one I have to simplify this expression with exponents. So I'm going to rewrite this all in base 2. So 16 is 2 to the 4th times the 2a plus 2 to that power. And we're multiplying that by 4, which is 2 squared, and that's being raised to the a minus 5 power. And that's all over 32 to the a, so that's 2 to the 5th, and being raised to the a power. So if I continue to simplify down here, we'll have 2 to the 8a plus 8 times 2 to the 2a minus 10 over 2 to the 5a. So 8a plus 2a is 10a, and 8 minus 10 is minus 2, so 2 to the 10a minus 2 over 2 to the 5a. And so when I subtract, then I'll have 2 to the 5a minus 2. When I subtract this 5a from the 10a, so that's going to be choice D. And number 2, the graph of 2 to the x plus 3. I know that a graph of 2 to the x power is going to look like so, and the asymptote will be the horizontal axis, the line y equals 0, and that this is a shift up by 3, a vertical shift up of that graph, so that looks like choice B. This would just be y equals 2 to the x power. Okay, number 3, I've got 2 equations. I'm going to write both sides, and one's already in base 2. The 1/8 is 2 to the negative 3, and that's being raised to the second power. So I get 2 to the 3x minus 1 equals 2 to the negative 6. And so now I can equate the exponents. So 3x minus 1 is negative 6. 3x is negative 5, so x is negative 5/3. So that's choice B. Number 4, I've got a 27 on one side and 9. I'm going to write this in base 3. So 3 to the 3rd times 2/3 k, because it's being raised to the 2/3 k power, equals 3 to the negative 2, which is the 1/9, to the k plus 1 power. So those are going to be multiplied. So this is 3 to the 3's cancel here, 2k is equal to 3 to the negative 2k minus 2. So now I can equate those exponents. So 2k is negative 2k minus 2, so 4k is negative 2, so k is negative 1/2, and that's choice C. Okay, so number 5, I've got to add these two. This is an exponent and this is an exponent, and I have to figure out what they are and add them to get a value. So the exponent that I raised 4 to get 32, let's just make it x. And I'm going to write these both in base 2, so 2 to the squared, so 2 to the 2x equals 2 to the 5th. So equating those exponents, 2x equals 5, so x is 5/2. So this one has a value of 5/2, and then this one, the exponent I raised 2 to get 32, is a 5. So I'm adding 2.5 plus 5, so I get 7.5, which is choice A. Number 6. I'm going to write this out again. The exponent I'm raising 3 to, I have to raise 3 to a power, and I have to raise 3 to the exponent that I raised 9 to get 27. So what I want to do is figure out what's the value of this, if I can, and then I'll raise 3 to it. So the exponent I raised 9 to get 27, if we just call that x, 9 to the x equals 27. Writing those both in base 3, 3 to the 2x equals 3 to the 3rd. And now equating the exponents, 2x equals 3, so x is 3/2. So this says take 3, and the value of this whole thing now is 3/2, and raise it to that power. So this is 1.5. I can think of this as 3 to the 1 times 3 to the 1/2, which is going to be 3 times the square root of 3, for choice D. Number 7, I've got to write this as a single logarithm, and it looks like it's all in base 10 because I don't see a base written in. So I'm adding the w and the v and subtracting the 3 log z, so this is going to end up being the common log, or the log of. So in my numerator, I'm going to have a w and a v, and in the denominator, this 3 is going to go back up on top of the z, so I'll have a z to the 3rd power. So which one? That's B. Okay, same kind of thing. I'm using the log properties in number 8. I'm going to take this apart. So if I just did this one step at a time, it'd be the log of m squared minus the log of 2 minus the log of n. And so now this 2 will come down to the front. So I'll end up with 2 log m minus log 2 minus log n, for choice C. And that's page 1.